Okay, last example. Example 9 is only asking us to find the points of inflection for y equals tan x on a restricted domain of negative pi on 2 to 5 pi on 2. Now, in the previous question, we looked at that restricted domain, but we just left it alone because we were dealing with a sine function, and the sine function has no non-permissible values, but tan, unfortunately, does have some non-permissibles. So we're going to have to look at this restricted domain and see where those asymptotes are living. So remember that tan is sine x on cos x. So wherever cos x is equal to 0, we have vertical asymptotes happening. Okay, so where does cos x equal to 0? Those are going to give me vertical asymptotes, which are non-permissible values in my domain. So they aren't allowed to be points of inflection because they're asymptotes. Okay, so cos x is equal to 0. If you think about your tan graph, I don't know if you know remember what it looks like, but it's kind of this lightning bolt thing with asymptotes, and those asymptotes are happening where cos x is equal to 0, which is pi on 2 and 3 pi on 2. But we have a domain that goes beyond 0 to 2 pi, so we have to think backwards. There would be a vertical asymptote at negative pi on 2. And then if I continued my graph moving forward, there would be another asymptote happening at 5 pi on 2. Okay, so we have 4 non-permissible values or vertical asymptotes, right? So x cannot be plus or minus pi on 2, cannot be 3 pi on 2, and cannot be 5 pi on 2 as we move forward in this question. Okay, we still want to put them on our interval chart. We still want to think about them and know that they would be vertical asymptotes if we were doing a full curve sketch. Okay, so since this question's only about points of inflection, we're going to find our first and second derivative right away because we need to analyze the second derivative. All right, so the first derivative would be the derivative of tan, which is secant squared, and I'm going to purposely write it like this because I need the second derivative, and I like to see it like that when I do my chain. So the second derivative would be pull the 2 down, keep the inside, reduce the exponent by 1, that's the outer, and then the derivative of secant is secant x tan x, and so that leaves me with 2 secants, 2 multiplied by secant squared x multiplied by tan x, and this is equal to 0 so that I can evaluate my significant numbers. Okay, so the third thing I'm looking at is finding those significant numbers. I could just divide the 2 out so that it makes it an easier factors. So this would just be equal to secant squared tan x, and those are your 2 factors. All right, right here we have secant squared and tan x. Those are my 2 factors. So first one would be secant squared x is equal to 0. Square root that just tells you that secant x is equal to 0. And so then I'm going to be looking at what's his reciprocal identity, 1 on cos x. When does that equal to 0? So really this is saying when we're finding significant numbers, it's not only when it's equal to 0, but also when he would be undefined. Okay, and so the secant graph is going to be undefined when cos is equal to 0. That's the part that we're going to be looking at, because we're never going to get 1 on anything is never going to be 0. So that part of finding a significant number doesn't give me a solution. But the other part, where it's undefined, is going to give me solutions. And those are the same solutions that we just looked at on our tan graph. Those are those vertical asymptotes happening at. So this part here, when does cos x is equal to 0, is going to be the part of the significant number that's undefined. And that is happening at those vertical asymptotes where it was plus or minus pi on 2, 3 pi on 2, and 5 pi on 2. So again, those are actually vertical asymptotes. So we want to pay attention to those not being allowed to be points of inflection. And then the second factor was tan. So when could tan be 0 or undefined, right? We're looking at both of those scenarios. So tan is sine x on cos x. So really, I'm looking at where sine x would be 0, which would give me the answer of 0, and where cos x is equal to 0 would give me the undefined piece, okay? So I'm looking at both of those. So when does sine x equal to 0, and when does cos x equal to 0? Well, we've already covered that one, but where does sine x equal to 0? So sine x is equal to 0 on the x-axis. So at 0, pi, 2 pi, 3 pi, etc. Those would be my numbers, but 3 pi would be beyond my domain, and negative pi would also be beyond my domain. So those would be the significant numbers that are coming out of the sine. And then the cos x answers are the same as what we just found right here, and those are vertical asymptotes. So these three right here, 0, pi, and 2 pi, are really the only possibilities for my points of inflection. But when I go to do my analysis, I still want to include my vertical asymptotes on my analysis, because if I was ever doing a full curve sketch analysis on this question, I would want to know what was happening. Okay, so this is a really ugly number line. So we're at negative pi on 2 all the way to 5 pi on 2. And we have 0, and then we had pi on 2, and then we have pi, and we have 3 pi on 2, and then we have 2 pi. So I could have spread that out a little better. Sorry. That's okay. We'll just, oh, didn't mean to do that. All right. There we go. Okay, so those are our numbers, and I like to put in my vertical asymptotes so that I know that this is a vertical asymptote. I know this one's a vertical, 3 pi on 2, 5 pi on 2. So those are all vertical asymptotes, just so I'm aware that those won't be points of inflection. And then again, feel free to plop those all into degrees so that maybe it's easier to decide what you want to test. So 270, 360, and I'm having problems doing my math today, guys. Oh, goodness. 450. Okay, so what am I going to test? I'm going to test negative 45, positive 45, 135, 225, 315, and 405. Those are what I chose. And then you're just going to plop those into your second derivative to figure out your signs. Did it come out to be positive or negative? So when I put in my negative 45 degrees, or the negative pi on 4, if you're working in radians, the answer came out negative. When I put in positive pi on 4 or 45 degrees, it was positive. Then it went negative, positive, negative, positive. Okay, feel free to pause the video and verify those in your calculator. What does that tell me about my function? That tells me that my graph is going concave down, concave up, concave down, and it's going alternating, concave down, concave up. Okay, and what I will do now is carry those vertical asymptotes down. Okay, so I have a vertical asymptote happening at the negative 90, the positive 90, 270 out here on the extremes. So that means that between the between the 45 and the 135 that I tested, even though it went from concave up to concave down, that can't be a point of inflection. So I only end up with 3 points of inflection. There's one happening here at the 0, there's one happening at pi, and there's one happening at 2 pi. So 0, pi, and 2 pi. The other ones are vertical asymptotes, so they can't be points of inflection. All right, so the last thing to do then is just to figure out what those y values are. Okay? Because a point wants both. So the first one would be to evaluate f of 0. So put 0 back into the original function, which was tan. So tan of 0 would be the same as saying y on x. So at 0 radians, I have the coordinate points 1 and 0. So 0 divided by 1 is 0. So the point there would be 0, 0. And then when we're doing f of pi, or tan at pi, then we're on the other side here. But the coordinates is negative 1, 0. The y coordinate is still 0. So 0 divided by negative 1 is going to be 0. So my next point of inflection will be pi and 0. And then lastly, at 2 pi, hopefully you realize that it's also going to be the same because the y is 0. 0 divided by positive 1 is 0. And so my last point of inflection for my restricted domain is 2 pi on 0. There we have it. You can write it out if you wish. That's a funky little 0. I don't know why I did that. Okay. So therefore, my points of inflection are 0, 0, pi, 0, and 2 pi on 0. Fini! Lesson 7.3 is all complete. Now, if you wish to give a couple of questions on your own a try, there are a couple of U-tries to try, and I will post the full solutions in the D12. So there is even a full curve sketch analysis. See how that goes for you. It would be super fun. There's a product rule. There's a lot of good practice in that question. All right. I'll see you for applications in 7.